Why do soccer balls curve? Here's an example. Magnus force. Magnus force is the main cause of a soccer ball's curve. Here, Lily will be asking Miss Spicer what Magnus force is.
I saw a lot about Magnus force and how that was involved. Could you also explain what that was?
If you have an object that's moving through a fluid of some kind, let's say this is like a ball that's moving to the right, even if the air is relatively stationary, like these are all my little air molecules. If they are stationary and this ball is moving to the right through this fluid, that means that the air molecules are more or less moving this direction relative to the ball. That's the general direction that the air is going to flow, but it likes to flow in what's called laminar flow, which means that it likes to avoid having turbulence at boundaries. So if you get like little whirlpool effects in here, that's turbulence, and that really increases the drag. So since all fluids have some kind of viscosity, it likes to basically stick together a little bit through those intermolecular forces. So they like to get this laminar flow which basically means that it flows in a smooth stream. So I'll draw a couple more arrows. So this is roughly going to be the flow of the air around the ball as the ball moves this way through the air. And this ball is also spinning. Then something additional happens, which is cool, which is that this bottom surface, which I will highlight with this bottom surface is moving faster, and this purple surface is moving slower. And what I mean by that faster and slower is that the bottom is faster relative to the air, whereas the top is slower relative to the air. If you have some spin on this ball, I had said that the top part of the ball is moving slower relative to the air, whereas the bottom part is moving faster relative to the air. What that's going to mean is that the fluid on one side is traveling faster than the fluid on the other side relative to the ball, and that's going to create a pressure difference. So the fast fluid is going to have lower pressure, and then the slower fluid is going to have higher pressure. So that's going to create a lift force. And I drew it backwards. So unfortunately, my lift force is now down. The main idea is that one side has the wind or the air traveling faster relative to the ball, and the other side is slower because of the spin. And then that creates a pressure difference, which points from high to low. So that's going to give you your lift force. And people call this the Magnus lift force.
Mrs. Spicer explained in her definition of Magnus force that the faster a fluid flows, the lower pressure it will have. This is called the Bernoulli effect. Let's go back to the Magnus effect. You may be asking, how does the Magnus effect relate to a soccer ball curve? The answer is actually quite simple. We all know that Magnus force affects a soccer ball's spin, and with a better spin, there will be a better curve. So therefore, with more Magnus force, the ball will curve better. For example, there is somebody kicking a soccer ball. When he kicks the ball, he puts spin into the ball, which causes the ball to curve. That curve causes the ball to veer towards the goal. So to answer the question from the very beginning, why do soccer balls curve? They curve due to a spin caused by Magnus force.